Quadratic application problems. Quadratic keywords. Some of the keywords we learned in our last unit are zeros, the y-intercept, and the vertex. Our zeros, also referred to as the x-intercepts, solutions, roots, are usually our ending point. Our y-intercept in application problems is typically our starting point. So even though you might think your starting point is here, actually it's your y-intercept, and we'll talk about that in a moment. And our vertex, our minimum or our maximum, that's the highest point. So typically, when you're talking about an application problem, your application problem is usually starting at your y-intercept. So if I'm thinking of this parabola as a ball, my y-intercept would be my starting point. Obviously, we're not starting at zero. We're starting above ground because this would be considered the ground. And typically, this is the air. So my starting point would be here. My vertex would be my highest point, and my zero or x-intercept would be my end point. Now, the reason we don't typically use this is because many times your x-axis represents time or distance in measurements. So we don't have negative time or negative distance. And our height is usually measured by our y-intercept. So typically we don't have a negative height. So that's the reason we only talk about positives in our application problems most times. All right, in the new hit Super Jump video game, you beat the final level by making your character leap off a truck to catch his enemy. Your character follows a curve y equals negative 2x squared plus 4x plus 6 as he leaps to capture his nemesis. Complete the table of values below to find his location at various points during his jump. So we're going to go ahead, look at our x value is 0. What's the y value? So here is 5, so that would be that point, which is 6. Okay, when x is 1, our y value is here, which is 8. When x is 2, our y value is here, which is at 6. And when x is 3, our y value is 0. What is the vertex of this graph and what does it represent? So remember, our vertex means our highest point. So in our application problem, this point here is our vertex. And it's in a vertex, whether it's an application problem or a non-word problem, our vertex is still going to be our highest or lowest point. So in this case, our highest point, which is this location here, and that point is at 1, 8. Okay, and what does that represent? Well, time is our x, height is our y. So it took 1 second for him to reach the highest point of 8 feet. Next question. What is the y-intercept of this graph and what does it represent? Well, our y-intercept is here, and that point is at 0, 6. And what does that point represent? Well, remember, he started his jump from a truck. So this is the height of the truck. This is where he started his jump. Question 3. What are the x-intercepts of this graph? Well, although the parabola goes down and continues on this way, our x-intercept that we're going to refer to in this scenario is here, and that is at point 3, 0. Remember, that's where he lands. So he started his jump from the truck up, and then gravity forces him down all the way to the ground. And then next question is, why are two of your y values or heights the same? So our heights are here, and we have a point here, which is our starting point, and we also have this point here. And if you recall, he jumps up and then he starts falling down. So there's two reasons. One is he started at 6 feet, and then due to the course of gravity, he also hit 6 feet on his way back down towards Earth. And question 5, why are there only positive values for x and y in this problem? So like I mentioned earlier, time is our x value, so we're not going to have negative time. And then the height is our feet, and if this is the ground, we're not going to be having him jump underground. That's the reason we don't have any negatives in this scenario. Next question is, what's a reasonable domain and range? So if you recall from the last unit, our domain was always all real numbers. But in real life scenarios, such as this type of scenario, your domain's not going to be all real numbers because we have starting and stopping points. So you need to think, what's your lowest x value and what's your highest x value in the scenario? Well, our lowest x value was at 0. So our lowest is at 0 here. And the highest is here, which is at 3. So our x values are between 0 and 3. 0 is our lowest, 3 is our highest. So 0 is less than or equal to x is less than or equal to 3. The next question is a reasonable range. So again, although in theory your parabola would go down on to infinity and your highest would be at 8, we actually have a lowest y value. Our lowest y value is at 0. The highest y value is at 8. So our range would be between 0 is less than or equal to y is less than or equal to 8. Because again, our range in this scenario is between 0 and 8. All right, go ahead and read through these answers and make sure if you have any questions, let me know. Make sure your notes are filled in completely. Firefighting. Smoke jumpers are in free fall from the time they jump out of a plane until they open their parachutes. The function y equals negative 16 t squared plus 1600 models and jumper's height y in feet and t seconds for the jump from 1600 feet. How long is the jumper in free fall if the parachute opens at 1000 feet? So let's go ahead and enter that into Desmos. Now remember, we can only use x and y when we're entering it into Desmos. So I've already typed this in for us. And if you notice, I changed my t to the value for x. And I'm going to go ahead and take a look at this parabola. Now, remember, he's up here at the airplane when he drops off. And so it said, how long did it take him to go into free fall? So we're going to go to 1,000 feet. So you might notice that in our parabola, there's two places that have 1,000 feet. One over here on the left, but that's negative, and we can't have negative time. So even though that's a 1,000 feet, we need to look at the positive. So we're going to go to about 1,000 as close as I can get, which is about 6.12 seconds. So he was in free fall for 6.12 seconds. Falling objects. Suppose you're tossing an apple up to a friend on a third-story balcony. After t seconds, the height of the apple in feet is given by h equals negative 16t squared plus 38.4t plus 0.96. Your friend catches the apple just as it reaches its highest point. How long does the apple take to reach your friend? And at what height above the ground does your friend catch it? So we're looking for the highest point, which is called our vertex. So type in your equation using x's and y. So our x value is our time and our y value is our height. So I've already typed that into Desmos. I'm looking for my highest point, which is my vertex. So remember, our x value is the time and our y value is the height. So it took 1.2 seconds to reach the height of 24 feet, which is the highest the apple was in the air. Okay. Next question, baseball. The path of a baseball after it has been hit is modeled by the function h equals negative 0.0032 d squared plus d plus 3, where h is the height in feet of the baseball and d is the distance in the feet the baseball is from the home plate. What is the maximum height reached by the baseball, And how far is the baseball from home plate when it reaches its maximum height? Okay, so again, we're going to type that into Desmos, which I've already done for us, using X's and Y's. So here's home plate, okay? And it's probably 0, 3 because you don't throw the ball, or the ball doesn't go from the ground. It's up from where it hits the bat. And it said, where's it at the highest? So X was our feet time, and Y was our feet. So it took about 156 seconds to reach a little over 81 feet. So 156 seconds to reach the height of 81 feet. Okay, next question. This one's a little bit more challenging because we're going to be talking a little bit about negatives, because this is talking about a bed of pond. So remember, that's going to be underneath the ground. So we're going to be having negatives in this scenario. The bed in a pond can be modeled by 25y equals 2x squared minus 20x plus 1, where x and y are measured in meters and the x-axis matches the water level of the pond. 1. What is the width of the pond? 2. How deep is the pond? 3. At what distance from the shore does the pond reach its minimum? And 4. At 2 meters away from the shore, how deep is the pond? So we're going to go ahead and look at that. Now you might notice this is not in standard form, which means we need to get rid of our 25 by dividing it by each of our terms. So make sure you do that when you put it into Desmos. So once we do that, it says, what is the width of our pond? So here's our parabola. Now remember, we're only talking about the pond portion. And so it said the x-axis represents the ground level. So our pond is underground, right? Because that's how the water's held. So it said, what was the width, I believe, was the first question. What's the width of the pond and how deep is it? So the width, so from here, our starting point, to here, our ending point. So our width is the distance of x. So it's about 9.95, or about almost 10 meters. And the next question was, how deep is it? So our depth is here, our vertex, which is our minimum. So remember, our distance will be our y in this scenario because we're underground. So we're looking at the negative 1.96, but we're not going to say it's negative 1.96 because we want to know from here to here, which is the distance. So that's only 1.96. We're not going to use the negative because we're describing the depth of the water. Next question is, what's the distance from shore does it reach its minimum? So how far did you go over before you hit that minimum? So from here, how far did we go over? That would be our x value. That would be 5 meters. And then the next question was, at 2 meters, how deep is the pond? So 2 meters. Here's 2 meters. How deep is the pond? So let's go ahead and go down to 2. There we go. It's about 1.24 meters deep. Okay. Revenue. A model for a company's revenue is R equals negative 15p squared plus 300p plus 12,000, where p is the price in dollars of the company's product. What price will maximize the revenue and find the maximum revenue? Okay, so we want to know what price and how much is that revenue. So again, we need to make our p values become the x. The r is going to be our y. So our revenue is the y value. Okay, so type that into Desmos. And let me make sure I got the right one. Yes. All right, so we have our parabola here, and we're only looking for the highest point, called our vertex. So we're going to click on this. So remember, our x was our price, and our y was the revenue. So at $10, our highest revenue is $13,500. Okay, profit. The barber's profit, P, Each week depends on his charge C per haircut. It is modeled by the equation P equals negative 200 C squared plus 2,400 C minus 4,700. What price should he charge for the largest profit, and what is the largest profit? So how much should he charge, and what is the largest profit? Meaning P or Y value is going to be the profit. So we're going to type that into Desmos using X's and Y's. Okay, oops. Excuse me. Okay, here we go. So we want to know the highest point. So here's my highest point. X was our cost, so $6, and our highest profit was 2,500. So that would be our answer. X represented our cost, and Y represented our profit. All right, next question. Civil engineering. The photo shows the Verrazano Barrows Bridge in New York, which has the longest span of any suspension bridge in the United States. A suspension cable of the bridge forms a curve that resembles a parabola. The curve can be modeled with the function y equals 0.001432 parentheses x minus 2,130 squared, where x and y are measured in feet. The origin of the function's graph is at the base of one of the two towers that supports the cable. How far apart are the towers and how high are they? And what's a reasonable domain for this situation? So this one's a little hard also to understand it graphically. So we're going to make sure we represent our x's and y, which it has. Now I know this isn't in standard form, but for the purposes of what we're doing, we're going to leave it in this format, which would be considered our vertex form. So we'll leave it in that form. All right, so we have that typed into Desmos. And remember, this is a bridge, so our starting point is here. This represents the height of what? Our height of our tower, right? So our tower is almost 650 feet up in the air. So it doesn't start at zero. My tower is where the top of my tower is where my cable is going to start. My cable is going to run all the way across the bridge. And where's it going to stop? Well, it should stop at the other tower. So my tower should be exactly the same height on each side. So I'm going to look at about 650. Just a little bit. There we go. So the distance between the cables is our x value, and that is 4,260 feet. And how tall were the towers? About 649, almost 650 feet. So those are in two answers. My distance of my cables, 4,260, and the height of my towers is 649.7 if I want to round it. Okay. Oh, I'm sorry, we missed a question. What's a reasonable domain? So remember we talked about domains and how they're reasonable. So even though my domain goes all the way to infinity, where starting point would be here, which is my x value of 0, and the x value for the highest, remember we're going to go to that. Sorry, I forgot what the number was. 649. And so my highest x value is 4,260. So 0 is less than or equal to x, which is less than or equal to 4,260. All right, physics. The equation for the motion of a projectile fired straight up at initial velocity at 64 feet per second is h equals 64t minus 16t squared, where h is the height in feet and t is the time in seconds. Find the time the projectile needs to reach its highest point and how high will it go? What's a reasonable domain and range? Well, again, we need to change our t for time to x and our h for height to the y. And we also need to put this into standard form. So we need to put this, our t squared, first before the t. So this is already done for you. So I've typed it in. So here is our rocket. And I wanted to know about the highest point the rocket hits. So remember, our x is our time, so 2 seconds, and our y is our feet, 64 feet. So it took 2 seconds to reach the height of 64 feet. Our reasonable domain, so our domain is the highest and lowest x values. So let's go down to the x-intercept. So our starting point, or our initial part, it will be about 0, okay? And so x is less than or equal to x, which is less than or equal to our highest x value, which is 4. And then the range, again, we're going to start at the ground. So the lowest is 0, and our highest, if you recall, we talked about that highest y value was 64. So 0 is less than or equal to y, which is less than or equal to the highest value of 64. So hopefully that has given you some scenarios in real life that you can understand how parabolas can be helpful.